block diagram reduction, or you can also call it as block diagram algebra. So please pay attention on the technique what we are using to simplify these blocks. This technique is directly used in your GATE problems to easily solve any type of questions, right? This technique is directly used in your GATE questions to solve it, right? The reason is, see, when you have a simple problem, there is no need of constructing signal flow graph for that simple problem, right? So when you have a very simple problem, you will just see and tick the answer, right? So that seeing and choosing the answer, that approach is what we want in order to save time, and that approach we are going to discuss using these techniques which we discuss here, right? So let us say you have two blocks cascaded like this. The output of one block, let us say we have G1 of S. The output of this block is connected as input of another block, that is G2 of S, right? This kind of connection is called as Cascade Connection. What is that connection called as? Cascade Connection, right? So in this Cascade Connection, see, please be carefully observe this particular approach. This approach is very much important. That is what I'm saying. This approach you will use in your problems to simplify your questions very easily, right? So let us say you are giving X as input to this G1 block, right? If you are giving X as input to your G1 block, what is the output after this G1? Tell me, what is the output after this G1, everyone? X times of G1. Vikas Meena, very good. It is X times of G1, right? Now this X times of G1 is input to your G2. X times of G1 is input to what? Input to G2. So what is the output after G2? After G2, what is the output? It is X times of G1, G2. X times of what? G1, G2, right? So you just want to replace these two blocks with a single block, right? So you just want to replace these two blocks with a single block. The output of the block is what? Output of the block is X times of G1, G2. X times of G1, G2, input is X, right? So what is transfer function? Transfer function is nothing but ratio of output to input in Laplace domain, right? So G1, X times of G1, G2 divided by X. What is the transfer function of this block? It is simply G1, G2. That's it. G1 plus G2. It is very simple, right? So look at this approach. How are you going? How are you approaching at the output? See, you are giving X some random input in frequency domain. You are feeding some input and you are seeing the output, and you are taking the ratio of output to input, and you are getting the overall output, right? So the same way, let us say you have two blocks connected in parallel, right? So the next connection is parallel connection, right? So next connection is parallel connection. Parallel connection means the outputs of the two blocks are going to get added at some place, G1, G2, right? So these both get added here, and the output is common, and as well as you see the input is also common, right? So how will you obtain the overall transfer function for this? How will you simplify this into a single block, right? Just give some random input, right? Let us call X is the input here, right? So what is the output at this stage and output at this stage? Tell me the output at this stage. What is the output? Please concentrate on this approach. This approach is very much useful in simplifying your GATE questions, right? So the output here is what? X G1. You will come to understand that when you start solving the GATE problems, right? So X G1 is the output here, X G2 is the output here. So what is the overall output? X G1 plus G2. Overall output is X times of G1 plus X times of G2, right? So if you want to replace this with a single block, which is like this, the output is what? Output is X times of G1 plus G2, input is X, ratio of output to input, that is nothing but G1 plus G2 is the overall transfer function of this particular connection, right? Therefore, upon parallel connection of two blocks, what are you going to get? G1 plus G2, right? So let us look at the next connection. This is what is called as block diagrams, right? So let us say you have some block like this. You have some block like this. So you have a comparator just before the block. You have a comparator just before the block like this. And the gain of this particular block is, let us call it as some G. Not even G1, it is some G, right? So you have some summer. Comparator is also called as what? Summer, right? This is nothing but a summer. You already have the knowledge of these symbols, right? So let us say you have some X, or else you have some A as input at this terminal, right? A is input at this terminal and some B is input at this terminal, right? Tell me what is the output? Output is A, because see, here you are going to get A plus B. Therefore, output is nothing but A plus B multiplied by, right? Yes, Vikash Meena, very good, right? So, if I want to shift this particular summing point to the right of this, block, what modification should I do? See, I just want to shift this summing point to the right of this block. If I am saying both are equivalent, both should give the same output to the same inputs, right? I am giving A and B as inputs here. I will also give A and B as inputs here also. Here also I will give A and B as inputs, right? Then the outputs given by this system and this system both should be same, right? In order to make this happen, what should I do here? What modification should I do? See, just check what is the output coming to be here, right? So the output at this terminal is what? This is A times of G, right? So what is the overall output? It is A times of G plus B, right? So what is required is, there is a G term, a G multiple is missing with B, right? So in order to get a G multiple with B, what you will do is, within this particular path, to this particular path, you will add a block whose gain is G. Now look at the output. Output is going to be A times of G plus B times of G. A times of G plus B times of G. This is equivalent to A plus B into. So this technique is called as what? Shifting of summing point. If at all you shift summing points, you should follow this. Shifting of summing point. Shifting of summing points, right? If at all you shift summing point, you should follow this particular rule. Is it clear? So let us go through the next connection. That is, if we want to shift the summing point from right side to left side, if at all we want to shift the summing point from right side to left side, what modification should we do? See, let us say we have a block here, but the summing point is this side. Summing point is here. I am giving A as input here and B as input here, right? So this is G, and I just want to make it equivalent to what? I just want to make it equivalent to this. So now what modification should I do, right? So tell me, what is the output here? So the output here is A times of G plus B, A times of G plus B, right? So what is the output here? A plus B multiplied by G, A plus B multiplied by, right? So let us see here. So if I am going to convert this into this, right? So what should I do here? I should add a block of 1 by G here, right? If I add 1 by G, so I'll get A and B by G here, so that I will get AG plus B at the output. So that is a modification which I need to do, right? So just note it down. We'll see shifting of takeoff point also. After that, we'll see a few problems which are very interesting, and you will come to know why we have learned all these techniques, right? So just note it down. We'll go for shift of takeoff points. Can I erase this top one? Right. So the next one is shift of takeoff point. So let us say we have a takeoff point like this, right? So this is what is called as takeoff point, the point from where you're tapping and taking the signal, right? So that is called as takeoff point. This is what is called as takeoff point, right? So I just want to shift this to the left of this block, right? So this is the location of this takeoff point is to the right of this block. I just want to shift this to the left side, right? In this case, what modification should I do, right? So just go through the conventional approach. What you will give some random input x, right? So if you are giving x, what is the output you get? That is x times of g here, x times of g here. The same way, if you are giving x here, you should get x times of g here and x times of g here. But actually, this x is directly getting transferred from here to here. Therefore, x times of g you are not getting, you are getting x, right? So in order to get x times of g, what should I do? What modification should I do in this path? I should just add a block. I should just add a block whose gain is g, right? So that this becomes xg. Yes or no? The same way, let us look at the shift of takeoff point from left to right. If you want to shift the takeoff point from left to right, what you should do, right? So see here. Next, you have some takeoff point before this block. To the left of this block, you have some takeoff point like this. You just want to shift this to the right, right? So this is G. What modification should I do now? What modification should I do now? So tell me, what is the modification required? Yes, 1 by G, right? So if I am giving x here, I'll be getting x here, I'll be getting x times of G here, right? If I give x here, I'll get x times of G here, I'll get x times of G here also, right? So I want x signal out of this. If I want x signal out of this, what I should do? I should add a block whose gain is 1 by G, so that I'll get xg multiplied by 1 by G, it is x, right? So that's simple, right? So once you're done with all these techniques, let us look into the questions now. So let us look at this particular question. You just simplify this and tell me the answer. This is a question given in ECE 2016 for 1 mark, right? Very simple question, you will easily solve it. Just simplify this and tell me the answer. Of course, you can solve this particular example, this particular problem using signal flow graphs also. But why to use signal flow graphs? See, whenever a problem will be solved by a needle, why do you use a sword for that, right? Some problem which can be solved using a needle, why do we need to use a sword there, right? So signal flow graph is a complicated technique and we don't need to use it here, right? We can just simplify this easily. If you want options for this question, I can give the options, but options are not required for this. Question is so easy. See, these are the options. So please go through the question and give me the answer, everyone. See here one most simple thing you have here is, see, this is some G2 block. From here you have a completely different section, that is G1, H1. See, you can see a feedback loop here, yes or no? We have seen a basic negative feedback loop, right? So what is the overall transfer function of this particular section? Tell me the overall transfer function of this particular section, right? See, you can see a small minor feedback loop. What is the overall transfer function of this particular section? Tell me. Can anyone tell me what is the overall transfer function of this particular section? It is G1 upon 1 plus G1 H1, right? It is G1 upon 1 plus G1 H1. So see here. So this is this particular block this is this particular section. What is the overall transfer function of this particular section? So now we can simplify this as what? We can simplify this as G2 here, G2, and this we can replace with a single block. And what is that block? That block is nothing but G1 upon 1 plus G1 H1. G1 upon 1 plus G1 H1. Right? So this can be simplified into this. Right? This section, see, you can see a small section like this, yes or no? Closed loop negative feedback. Yes. So I've just replaced this section with a single block, that's it. There is nothing else. I've just replaced this entire section with a single block. Is it clear? Right? So this is being cascaded with this. This is being cascaded with this particular section. Right? So if this is being cascaded with this particular section, then see, this block multiplied by this block will be this block multiplied by this particular block will be this entire section. Right? So now how can I simplify this in the next step? The next step is going to be G1 G2 divided by 1 plus G1 H1 in the feed forward path, G1 G2 divided by 1 plus G1 H1 in the feed forward path, and a unity feedback in the feedback path. So can you simplify this and tell me the next step? Can you simplify this? This is simpler. This is similar to G of S by 1 plus G of S H of S, right? So the overall transfer function is going to be what? G of S, let us say G of S is G1 G2 by 1 plus G1 H1 divided by 1 plus G1 G2, right? So this is G1 G2 by 1 plus G1 H1 divided by 1 plus G1 G2 divided by 1 plus G1 H1. G1 G2 divided by 1 plus G1 H1 divided by 1 plus G1 G2 divided by 1 plus G1 H1, right? This is going to give G1 G2. See, if I take LCM, the denominators are going to get cancelled, right? So this is 1 plus G1 H1 plus G1 G2. This is the overall transfer function. Therefore, which option is your right answer? The right answer is the last option. Sorry, it is B only. It is B only. Sorry. So, is this clear to everyone? Is it clear or not? If we have some amplifier between input and output, my input is some 1. Let us say the amplifier gain is some 5. The output will be is equal to 5, right? So, if we have a straight connection like this between input and output, if my input is 1, the output will also be equal to 1 because the gain of this is going to be how much? 1. The gain of this path is going to be 1. And that is the reason why I have considered it to be how much? 1. See here. So we have this particular feedback loop, right? Right? So what is the overall transfer function of this? We have already discussed. Right? Overall transfer function of this is G of S upon 1 plus G of S H of S, right? So in the place of G of S we have G1 G2 by 1 plus G1 H1. In the place of G of S we have G1 G2 by 1 plus G1 H1, right? So let us call it as some X. For your convenience, I am calling it as X, right? So if G1 G2 by 1 plus G1 H1 is X divided by 1 plus, what is H? H is equal to 1 here. H is equal to 1. Therefore, X divided by 1 plus X. This is what I have written. X is what? X is G1 G2 divided by 1 plus G1 H1. Therefore, X divided by 1 plus X. That is what we got. You have one more approach available for this. Just apply a random signal X here. A random signal X, right? So if you apply a random signal X here, right? So what will you get here? It is X times of G2, right? X times of G2 is fed here, right? So in this way you can proceed. You just try in this also. You can try in this way also. You just proceed and try and get the answer. If you don't get the answer, you can ask me, right? So let us look at the next question now. Consider the following block diagram in the figure, right? The transfer function C of S upon R of S is. You have to compute the ratio C of S upon R of S is. I'm not elaborating this particular procedure because we have done questions like this. We have done the procedure like this, and we'll use the same approach to remaining questions also, right? You just try this at home and tell me you got the answer with this approach or not. You can designate output with C and you can designate input with R. You have to calculate the ratio C upon R. Just mathematical simplifications, that's it. See, go through that approach, give a random signal X at the input and see what output you are getting. So there are different types of approach you can use to answer this particular question. See here, see G1, G2 and one more block you have plus sign everywhere, right? So the first approach, let us look at the first approach. Let us put some input, random input X here. If X is some random input, right? So what is the output here? It is X times of G1, right? What is the output here? This X is straight away coming here, right? So this X is straight away coming here also, right? So what is the input to this G2? Input to this G2 is X times of G1 plus X, right? X times of G1 plus X multiplied by G2. So what is the output at this stage? At this stage the output is X times of G1 plus X completely multiplied by G1. So output at this stage is X times of G1 X times of G1 plus X multiplied by, sorry, this is G2 plus X. So this is equal to what? X times of G1 G2 plus G2 plus 1. If you take this X to be common, it is G1 G2 plus G2 plus 1. So input is X, output is X times of G1 G2 plus G2 plus 1. Ratio of input to output, you will get G1 G2 plus G2 plus 1, right? So which option is matching? Which option is matching? If you look at the options, option C, that is G1 G2 plus G2 plus 1 should be the correct answer. We'll use simplification methods, other simplification methods also, right? So this approach is what is very important, I've said, right? Giving a random signal and obtaining the output and calculating the ratio of input to output, that is also very important. Is it clear? Right. See here everyone. So you can consider this entire thing to be a single node, yes or no? This entire thing is a single node. See here, you can say this is a single node, right? So you can simplify this to be this way, right? G1, whatever you have, right? So you can easily simplify this in this manner, right? This is plus, right? Again, G2, the same node, from the same node, another connection is coming and it is adding up here. Is it clear? Right? See here, from the same node, we are getting two feed forward paths whose gain is how much? Gain is 1. If there is nothing like this, you already know the gain of this is what? Is it clear? So you can clearly see this and this are in parallel, right? This and this are in parallel, and this particular section is in cascade with G2, right? So this entire thing is in parallel with this one again, right? So this entire thing is in parallel with one again, right? So if this and this are in parallel, so G1 plus 1, you will get a block like this. So this red marked section is nothing but simply G1 plus 1. This is cascaded with what? This is cascaded with G2. This is cascaded with G2, right? So this has one more parallel one more parallel path, that is 1, right? So G1 plus 1 multiplied by G2, G1 plus 1 multiplied by G2, what you will get? G1 G2 plus G2. This block has what in parallel? This block has 1 in parallel. This block has 1 in parallel. Now you can add G1 G2 plus G2 plus 1. Is it clear? Right? So the resultant of this is what? G1 G2 plus G2 plus 1. Right? In this way you can step by step simplify the blocks, or else see here, if you go through all these steps, you have to solve it step by step, right? There is a necessity of writing it down every time, and it consumes time, right? Therefore, the simplest approach is what? Just give a random signal somewhere here, right? So if you give some random signal here, you will get the output, right? So just take the ratio of output to input, you will get the entire transfer function. So try this question. This is a very logical question. Please try this particular question. See, this is most important point. This is the most important point where you people commit mistake here, right? So we'll see this particular question. We'll see how simple is it, how confusionless this is when we use signal flow graphs. Also, we'll also use signal flow graphs to reduce this. Straight away, it is a very confusionless problem if we solve it using signal flow graph. So how to solve this? See here. See, this is negative sign, right? You have a negative sign here and you have a positive sign here, right? So this positive one is cancelling out this negative one, and you are getting what? See, let us say you have some X signal here, right? So what is the output of this stage? What is the output of this stage? What is the output at this stage? It is X divided by S plus 1. Yes or no? At this stage, output is X divided by S plus 1. Vikashmina, very good. Yes, Vasanti, very good. So what is the output at this stage? At this stage, what is the output? Here also it is X divided by S plus 1. Yes or no? So X divided by S plus 1, X divided by S plus 1, right? X divided by S plus 1 minus X divided by S plus 1. So what should be the output in this particular path? What should be the output in this particular path? It is 0, right? If 0 is getting multiplied with this, we can straight away eliminate this particular feedback path. Yes or no? You can straight away eliminate this particular feedback path. What is left, right? See, this block has no connection with the output, right? This is output, right? C of S. C of S is equal to what? X into S plus 1. This block has no connection with the output, right? So if this block has no connection with the output, this has no effect on the output. The only block which is affecting the output is what? This straightforward path. If you are feeding X here, you are not getting any feedback, you are getting 0 feedback here, which means X is straight away forwarded to here, right? So output is X divided by S plus 1, right? So input is X, output is X divided by S plus 1. What is the transfer function? Ratio of output to input, that is 1 by S plus 1. This is the overall transfer function, that's it. This is the overall transfer function. Is it clear, everyone? Right? So see, just use that smartness here, right? So if you put X here directly, when you have this feedback path present here, like this, if you put this X signal here at the input, right? In order to calculate the signal you are getting here, you should have the knowledge of output also, right? Output, or else you should have the knowledge of this, right? So using my brain, what I'm doing is I'm taking some random signal here, right? The difference of this as well as this signal, I'm calling it as X. That difference I'm calling it as X, right? So I'm getting the signal at this part and I'm getting the signal at this part. If both of them are subtracted, then the result here is 0, right? If 0 is flowing through this feedback path, there is no feedback at all. There is no effect of feedback at all, which means whatever you are giving at the input is coming at this particular stage like this, right? So if you take out the ratio of output to input, you will get 1 by s plus 1. Go through the next approach, next problem in this, right? So let us solve the next problem. The following problem, for the following system, when x1 of s is equal to 0, when x1 of s is equal to 0, what you have to find is the transfer function y of s upon x2 of s, right? So when x1 of s is 0, you have to find out y of s upon x2 of s, right? So please note down the question and find out the transfer function y of s upon x2 of s when x1 of s is 0. So basically, how you are applying superposition theorem on your system, what you are doing is you are turning off the other source when one source is present, right? When you have two input sources, you are turning off one source and finding out output because of that particular source, right? When you have when you have found out the output because of one source, you will be finding out the output because of other source by turning off the second source, right? So you will add all the inputs, right? The same way, even in control systems, if you have n number of sources, right? So using this Laplace transformation approach, if you have n number of sources, right? So if you want the output of the system because of this particular input x2 of s, what you will do is you will turn off this input x1 of s. If you want output because of x2 of s, you will turn off x1 of s, right? You will make x1 of s to be 0 and you will find out the output because of x2 of s, right? So the same way, y of s upon x2 of s, you will find out when x1 of s is equal to 0. So that is what is asked in the question. Yes, that is what is asked. You will turn off this particular source to 0, right? So see here, so I am turning off this source, which means I am removing this x1 of s. I am removing this input x1 of s. So which means in the place of x1 of s, you can think I am giving 0. You can think I am giving 0 in the place of x1 of s, right? So let us say C of s is your output, that is C is your output, right? If C is your output, if x of s is 0, then what is the error? This minus C is how much? Minus C. You are getting minus C here, right? So minus C is getting multiplied with s by s plus 1, right? So you can rewrite this in this form. You can rearrange this and rewrite this particular block diagram in this form like this. See here, it is 1 upon s. The input is what? Input is x2 of s and the output is c of s, right? So here, is this plus? Yes, this is plus. So minus is getting multiplied with s here, minus s by s plus 1. So you can simplify this in this manner, right? So this is a positive feedback system, you can see, right? So you can call this as G, this as H. What is the overall transfer function? Overall transfer function is G by 1 minus GH, right? So overall transfer function is G. What is in the place of G? In the place of G you have 1 by S by 1 minus 1 by S multiplied by minus S by S plus. So this S and S gets cancelled. This minus and minus becomes plus, right? So it is, if you just simplify this, or else I am writing the next step also, it is 1 plus 1 by S plus 1. So what you will get? It is, if you simplify this, you will get S plus 2 in the denominator, that is S plus 1 plus 1, that is S plus 2 in the denominator, into S in the numerator you will get S plus 1. So this is how you will get the answer. So see here, how this has been converted into a negative mark. See here, the only thing is, see, whenever you have more than one sources, how you will find out the overall transfer function, the simplified block. Okay, this one I will tell you someone with us how, right? So whenever you have more than one sources, you will turn off one source and you will find out the output because of a single source, right? So here it is already asked, if you are turning off x1 of s, then find out the output of the system with respect to the second input, right? So transfer function of the system with respect to the second input, right? So you have turned off x1 of s, right? Therefore y2 of s upon x2 of s when x1 of s is equal to 0, that is what you need to find out. Therefore when your input is 0, right, input is 0 and output is getting deducted from your input, right? So if c is the output, you will get minus c here. Yes or no? You will get minus c here. This minus is getting multiplied with this block, and that is the reason why I've been using minus s by s plus 1 here and plus sign here. Or else I can do one more thing. See, instead of taking minus sign here, I can take plus sign here, right? I can take plus sign here and I can use minus here. You will get the same thing, right? So I'm just rearranging this particular thing in this manner, right? So if I just remove this, yes. So as the input is 0 and it is the output is getting deducted from 0, output is directly multiplied by minus 1. That's it. So that minus 1 I'm reflecting here, right? If you are reflecting minus sign here, you should use the sign as it is. If it is positive, you should use positive. If it is negative, you should use negative, right? So if it is not like that, right, then what you should do, right, if at all you are not retaining the sign here, you are using plus here, you can use minus here, right? So both ways you will get the same answer. This is what you are saying, right? C of s will be here at h also. So have you got the procedure, everyone, right? So once you get this, the remaining is same. See, one thing, the basic things now you should that should be left in your mind. That should be you should be remembering it, right? So the overall transfer function of any negative feedback closed loop system is what? It is simply g of s upon 1 plus g of s into h of s, right? So you will use this infinite number of times in control systems, right? So this should be in your mind. If whenever I ask what is the overall transfer function of a closed loop system, you should say g of s by 1 plus g of s h of s is the overall transfer function of a closed loop system. If overall transfer function would have been asked, then we will add the results for x1 of 0 and x2 of 0 when x2 is equal to 0 and x1 is equal to 0. So let us go for the next problem also. By performing cascading and or summing or differentiating operations using transfer function blocks G1 and G2, one cannot realize the transfer function of the form, right? See, he has given the operations cascading, summing, differentiating, right? So let us look at the options one by one. First option is G1, G2. G1, G2. By cascading, you can easily implement this particular thing, right? Whereas, look at the option C. Option C is what? If you simplify option C, this is option A. If you simplify option C is G2 multiplied by 1 by G2, G1 multiplied by 1 by G1 plus G2, right? If you simplify this, what will you get? G1 plus G2. Using summing or differentiating, you can get this, right? Using paralleling of blocks, you can get this, right? So let us look at the third option. It is B, G1 into 1 by G1 minus G2. So this is nothing but, this is not this, this is 1, right? So using this 1 minus G2, you can get this also using differentiating, right? The only thing that is not possible is what? G1 plus G1 divided by G2. So you cannot implement G1 divided by G2 using any of these techniques, that is cascading, paralleling, or any of these techniques. Using any of these, you cannot ever obtain G1 plus G2. Therefore, the correct answer for this question is what? Option B. Option D is the correct answer. Clear?